We are covering differential leveling, specifically the height of instrument method and loop closure, a key topic in the surveying section of the FE civil exam. This process is fundamental for determining the relative elevations of different points, a common task in construction and site design. The core of the HI method revolves around two simple equations you'll find in the surveying chapter of the NCEES FE Reference Handbook. First, the height of instrument, or HI, is the elevation of your level's line of sight. You calculate it by adding your backsight reading to a known elevation. The formula is HI equals known elevation plus backsight, or BS. A backsight is always a reading taken on a point of known elevation, like a benchmark. Once you have your HI, you can find the elevation of any new point by subtracting the Foresight reading from the HI. A Foresight, or FS, is a reading on a point where the elevation is unknown. For example, if you set up your level and start at benchmark A with a known elevation of 350.50 feet, and you take a backsight reading of 5.25 feet, your HI is 350.50 plus 5.25, which equals 355.75 feet. Now, to find the elevation of a new point, say point B, you would take a Foresight reading on it. If that reading is 3.10 feet, the elevation of point B is 355.75 minus 3.10, resulting in 352.65 feet. Exam questions frequently involve a series of setups. When you need to move the level, the point you last took a Foresight on becomes a turning point, or TP. From your new instrument location, you will take a backsight on that same turning point to establish a new HI, and then continue the process. This is a critical step and a frequent source of exam errors. A common exam trap is mixing up backsight and Foresight readings in your calculations. A simple mnemonic to remember the process is backsight adds to get the high sight, Foresight subtracts to get the ground right. This helps reinforce that a backsight reading on a known point establishes your instrument height, and a Foresight reading determines the next point's ground elevation. Now let's discuss closure. To ensure accuracy, surveyors perform a level loop, starting at a benchmark and ending back on the same one. In a perfect world, your calculated final elevation would exactly match the starting elevation. However, small random errors are unavoidable. The difference between the known starting elevation and the calculated ending elevation is the error of closure. The FE exam will test whether this error is within an acceptable range, known as the allowable misclosure. A typical formula for third-order leveling in U.S. customary units, which is common for ordinary construction, is C equals 0.05 times the square root of m, where C is the allowable error in feet, and m is the total length of the level loop in miles. Be extremely careful with units here. This is a classic exam trick. If a problem gives you a loop distance of 7,500 feet, you must first convert it to miles by dividing by 5,280 before using the formula. For a 7,500-foot loop, m would be approximately 1.42 miles. The allowable error would then be 0.05 times the square root of 1.42, which is about 0.06 feet. If your calculated error of closure is less than this value, the survey is acceptable. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.